Horizontal asymptote. What does horizontal mean? Horizontal line. It's going in a flat somewhere, yes? Now, the horizontal asymptote could happen in one of two ways. This is just an example. Yes, that is one possibility. And I'll put that two. So that horizontal line, we put a dotted line because it's an arbitrary line that just has the limit. So what is the equation of that line? Y equals 2. So that is the horizontal asymptote, the equation of the horizontal asymptote. Possibility number 1. Case 2. There is an asymptote, yes. What is the equation of that asymptote? Y equals 0. Is that another name for y equals 0? Huh?
Undefined.
Undefined. The equation y equals 0 corresponds to what line? Louder noise, how it's the
The x-axis.
The x-axis. Good. Next case. Another possibility. Yes. What is that equation? Last case. Y equals 0. Even though I didn't draw the code. That's so y equals 0. And of course, x-axis. One of the things. Later in calculus, one would want to know something called a limit. Calculus 1 would always start with limits. So we want to know the limiting behavior of a function. So this is a curve that's going along that dotted line. So technically, as you go farther and farther and farther, the function is going to get closer and closer and closer to that dotted line. But it will never become 2. Yes, going back to the concept of closed dot, open dot. If you put a closed dot, you are suggesting that you are including that value, correct? Open dot means you're not including, but it's still there. Which is why when I first started, I drew that arbitrary line and I put it in, as a dotted line and not a solid line. So this function, as it goes in that direction, in other words, x is approaching this value, positive infinity. So when x is approaching positive infinity, what value is the function approaching? 2. Will it ever equal 2? No. So that value 2 is the limit. Good. Okay. What about that case? As x approaches infinity, what happens to f of x? Will it ever equal 0? No. What is the limit? 0. X is approaching what value? Negative infinity. What value is the function approaching? Negative 2. Could it ever equal negative 2? No. What is the limit? Negative 2. Then comes the very last case that would, well, x is approaching what? Negative infinity. What is f of x approaching? 0. What is f of x ever be 0? No. What is the limit? 0. Again, these are deeply theoretical stuff beyond calculus, unless you get heavily involved in mathematics, you wouldn't get into limits and such. There is one thing that is common to all 4 graphs that I drew. What is it? Right. Okay, here's, but ignore the back part. We haven't got enough yet. So what else is there? They all have a horizontal asymptote. What else do we see? The limit is the horizontal asymptote. Okay, what else do we see? It has something to do with x. That's my hint. Huh? Okay. None of them cause the y-axis. Okay. Riley's making a very good point. Certainly, I could have crossed the axis. I didn't do it because I wanted to keep things simple. So, sure, I agree with you. Anything else? I wrote, the x's. There is something that you should see. Louder, Celsius, no one here can't hear.
They all go to infinity.
They all go to infinity. So, over here, positive infinity. Over there, negative infinity. Yes? So, what do horizontal asymptotes give us? Horizontal asymptotes simply give us the limit at positive infinity or negative infinity. Could you have a horizontal asymptote in both directions? Absolutely, you could have in both directions. When we use the calculator, you will see. And there are two cases. The cases where y is equal to some number. In other words, you have a horizontal line, or the case where it goes along the x-axis. Those are the two possibilities. And you can easily identify which type you will have just by observing something important. When do we get a horizontal asymptote that is not the x-axis, not in the keyword? In other words, you get a horizontal line, could be y equals 2, y equals negative 2, one of those, but not the x-axis. When does it happen? It will happen only under one condition. Numerator degree will equal denominator degree. If they are the same, then you will definitely have a horizontal asymptote, and that will not be the x-axis. Good. The degrees are the same. You should know what I'm referring to in terms of degrees, because when I started, I wrote a rational function to be the ratio of two polynomials. So the degree of the numerator polynomial and the degree of the denominator polynomial, if they are the same, then you will have a horizontal asymptote that is not the x-axis. Good. That would leave us with one case. Horizontal asymptote, that is y equals 0. In other words, x-axis. This will happen under one condition. I would like to preserve the order of the condition. The numerator degree is less than the denominator. One easy way to remember, if you have a numerator number and you have a denominator number, anytime the denominator number is bigger than the numerator, what do you get as an answer? 0. Now it's okay. No, that wasn't the question. If we have two numbers, just regular numbers, if the denominator is bigger than the numerator, what do you get? A fraction. To be specific, what kind of fraction? Less than 1. So in other words, between 0 and 1, you would get a decimal value. If that denominator kept getting bigger and bigger and bigger, what would the fraction get closer to? 0. Why equals 0? Easier way to remember instead of memorizing. So if the denominator degree happens to be larger than the numerator degree, you will always get a horizontal asymptote. That is 1 equals 0. Yes? That part's easy. And finding here y is not equal to 0. Condition very easy characteristics.
If the numerator is bigger, is there just no asymptote?
Yeah. It'll actually be positive infinite. So there is nothing to find when you have x-axis as the asymptote. But if you end up having a case that where x-axis is not a horizontal asymptote, but you do have a horizontal asymptote, how do you find it? All you have to do, well, the condition is the degrees have to be the same. Yes? So we know the horizontal asymptote could only happen if the numerator degree is equal to the denominator degree. Yes? So all I'm suggesting is we can easily find what that number, what that dotted line is going to be if we did an divided by bn. Both an and bn correspond to the polynomials. An belongs to the numerator polynomial. Bn belongs to the denominator polynomial. Having done polynomials all this time and the notation of polynomials, what is an called? What does an correspond to in the numerator polynomial? I will give you a hint. Blank, coefficient, fill in the blank. What? Where is this coming from? Oh, right.
Leading coefficient.
Leading coefficient. An is the leading coefficient of the numerator polynomial. Take a guess. What is the n? The second term's coefficient. Okay. This is in the denominator. Just a guess. Kate said an is the leading coefficient of the numerator polynomial. What could bn be? Louder. Can you hear that sound? No.
Leading coefficient of the denominator.
Can you hear that? Okay. Leading coefficient of the denominator. If the degrees are the same, all you have to do is to take the leading coefficient of the numerator divided by the leading coefficient of the denominator. I'm using P of x and Q of x because that is standard notation to refer to numerator and denominator polynomials. So all I have to do is to pick those two coefficients, divide, and I'll get a line that is not 0. Or y equals 0. Are we clear? Yes? Good place to stop.